chemical properties of the alkynes. So let's have a look at what are the chemical properties of the alkynes. So when we have a look on the alkynes, basically they are the unsaturated hydrocarbons. Unsaturated hydrocarbons means they have triple bond between two carbon atoms. As they are having triple bond between two carbon atoms, so they can undergo easily the addition reaction, and that addition is gonna to be take place at the triple bond, and in this way they can easily be converted into the saturated hydrocarbons. So the unsaturated hydrocarbon can be converted into saturated hydrocarbons by the reaction of the simple alkynes with the halogens or with the hydrogens. So by the help of addition reaction, we can have the saturated hydrocarbons from the unsaturated hydrocarbon. So let's have a look at what are the reactions. The first one chemical reaction that has been given by the alkynes, it is the halogenation. Simple, the halogenation means it is the addition of halogens, and these halogens are basically group 7A elements, and they are fluorine, chlorine, bromine, and iodine. And basically here we have the addition of bromine and chlorine and bromine. The fluorine, the reaction is very too fast or too vigorous, so that's why we do not use fluorine. And the reaction with the iodine, it is very slow. So we just use for the halogenation chlorine and bromine. So in this reaction, we have a catalyst, that is phosphorus trichloride, and it is a catalyst. So what is the purpose for the use of the catalyst? It is used to increase the rate of chemical reaction, or it is used to speed up the chemical reaction. We use the catalyst. So in addition to this, we can have the reaction with chlorine and bromine. So it is going to be happen in the two steps. The first one step of the reaction we have, this is the step 1. We will start from the simple alkyne, that is ethyne. So the ethyne is having triple bond and one hydrogen on this side and the second hydrogen on the other side, and we have the addition of the chlorine, Cl2. Then after the reaction we have a look that the one chlorine will be added on the carbon number 1 and the second chlorine will be added to the carbon number 2, and after the reaction we gain that now this triple bond will be converted into the double bond, and we have chlorine on one side and chlorine on the other side, and the hydrogen and the hydrogen. So this is the compound named as 1,2-dichloroethane. This is a step 1. After that we have the step 2. In the step 2 we have the reactant, that is the product of the step 1. So here the step 1 was very simple, and the step 2 is going to be start from 1,2-dichloroethane. So by the addition of the halogen atoms, next chlorine, we will add the product. Now this double bond will be converted into the single bond, and that chlorine will be added to the carbon number 1 and this chlorine will be added to the carbon number 2, and we have the product carbon, single bond carbon, and the chlorine carbon number 1 and 2 chlorine to the carbon number 2 and the 2 hydrogen. Now the name of this product is 1,1,2,2 tetrachloroethane. Ethane, because there are two number of carbon atoms are present. Tetra mean there are four chlorine atoms are present, and the number 1122 is going to designate the position of the substitute, that is chlorine. So this is a simple halogenation reaction of the alkynes. Next we have the second reaction. It is the oxidation with KMnO4. So the simple ethine undergoes oxidation, and that oxidation is going to be take place with the nascent oxygen and in the presence of basically KMnO4, and as a result of this we take we just have oxalic acid. So this is the simple reaction in which it gives carboxylic acids along with the carbon dioxide, in which the alkynes reacts with the nascent oxygen in the presence of KMnO4, and the products we gain are the carboxylic acid and the carbon dioxide. So let's have a look at what is the chemical reaction. So the main chemical reaction, we have a simple alkyne, carbon-carbon triple bond, and the hydrogen. So the name of this compound is ethine. By the addition of the nascent oxygen, we will have four atoms of oxygen, and as a result of the reaction, in the presence of potassium permanganese, the product that we gain, it is oxalic acid, C double bond O, C double bond O, hydroxyl group and hydroxyl group. So this product is oxalic acid, and basically oxalic acid is a acetic acid, not, it is a carboxylic acid, carboxylic acid, and along with the production of the carbon dioxide as a side product. So this is a simple reaction of ethine with the oxygen, that is known as oxidation with KMnO4. So basically these two reactions are known as the addition reaction of the alkynes. Addition reactions of the alkynes, and this is due to the presence of the triple bond between carbon atoms. So I hope you guys understand about today's lecture, the reactions or the chemical properties of the alkynes. And if you have any queries or confusion related to the topic, you can ask me about that in the comment section, and I will get back to you guys soon, inshallah. For that time, have a good day and Allah Hafiz.